So I'll be going over the previous problem of the week, speed limit on Caddis. It has a difficulty of 1.5, so it's not terribly difficult, but there's a couple catches that you might want to watch out for. So I'll be going over the problem first, and then a simple solution. So the problem statement has Bill and Ted taking a road trip, and you want to figure out the miles they've driven. So they record the speed and the total time they've driven in increments like this. So they want you to compute the total distance. So here's an example of what the input might look like. The speed in miles per hour and the corresponding the corresponding total elapsed time that this speed was traveled at. So this means that they drove 2 hours at 20 miles an hour, then 6 minus 2 hours at 30 miles an hour, 7 minus 6 hours at 10 miles an hour. So the distance driven would come out to 170 miles, as you can see here. So an important catch that you want to note is that this records the total elapsed time in hours. So you don't want to just do 2 times 20 and then 6 times 30. You need to remember to take the difference because to find out what the actual time is since the previous entry. So the input is going to consist of between 1 and 10 data sets, with each set starting with a line containing an integer n is greater than or equal to 1 and less than or equal to 10, followed by n pairs of values with 1 on each line. So in each pair, the first value is s, or the speed, and the second value is going to be the total elapsed time, or t. Both of them are integers, with s is greater than or equal to 1 and less than or equal to 90, and t being greater than or equal to 1 and less than or equal to 12. The values for t are always going to be in increasing order, so you don't have to worry about sorting anything. And the number that lets us know inputs over is going to be -1. So as for the output, you want to output the distance driven, followed by a space, and then followed by the word miles. So an example bit of code that I used for this was this. So here on the first line, we're taking the first integer, which, if you remember, would be n for the first input set. So the amount of pairs of values for the first set of inputs. So then we go into this loop that contains the bulk of the program. We have we want to keep this running until we hit the end of the input, which we know is marked by -1. So that explains this. And this for loop contains what we actually want to do for every value. It contains what we want to do, all of what we want to do for each individual input set. So because of that, we have these inside of this loop, because we want to set these values, elapsed time and distance, to 0 between every input set, so that we can let it restart, and they'll be justified further once we get into this block. So elapsed time is the the time elapsed before the current log entry or the current pair of values. So, for example, if we're going through this line, elapsed time would cover 6. If we're going through this line, elapsed time would be equal to 2. So we just want this so that once we get to a certain value, we can just subtract whatever this is from what we have stored in here and find how long this speed lasted for. So in distances, it's added to each loop, so we just want to keep it going, print the final value, and then reset it back to 0 before we start on the next input set. So this is how we're going to be handling each individual input set. So we'll run, the whole loop will run out until it ends, until it reaches the condition, once every single input set we have. So we have a for loop with however many times this gave us, or the number of pairs in this input set. We'll be running this loop for that many pairs, or that many lines. So then so we're going to be going and looping through each line, and so we'll take the inputs here to that end. And what we're doing here is we're getting the line with input, and then we're using split to separate it by spaces, and then we're assigning the first integer to speed and the second one to total time. However, you do want to note that input, it will return a string, so both of these are strings right now. So we'll just cast both of them to integers real quick. And then we're going to compute the distance because we have our values for one line. So here we have the distance. We're going to have whatever the total distance is for now, which at the beginning of the loop will be 0, of course. And then we'll add on to that the speed times the amount of time that speed lasted for, which is the total elapsed time for this entry minus the elapsed time for the previous entry. So we're going to update the elapsed time after that, so that when we restart this loop, elapsed time is now is what's currently the total time. So, for example, right here, after we multiply this out to be 120, we'll move on to working on this input and set elapsed time to this value. So we're going to repeat that throughout and finish a whole input set that way, increasing distance the whole way. And once we've reached the end, value for distance will be the total distance traveled throughout the entire input set. And then once we're done with that, we'll just print that value in the format specified, which, if you remember the format was the distance driven followed by a space followed by the word miles. And in Python, we can do that with just this, because a comma will automatically add a space between the two values. And then we're going to get the next input set ready by updating the value of records to the next number of pairs for the next input set. And then with that new value, we'll start back up here and continue the loop, printing the values throughout. So if we want to test it out, we have this sample input. I'll run it, and as you can see, the sample output would be 170 miles, 180 miles, 90 miles, and we have 170 miles, 180 miles, and 90 miles. And if you want to take this, submit it, and confirm that it works. Yeah. Yeah, it should pass all the test cases. And yep. So it might not be the most efficient solution, but this is the general logic you'll be following to solve speed limit